So hello, everybody. Welcome to what lurks beneath deep sea scientists with dynamic Earth. My name is Chris. I'm going to be doing the session today, and we've been working with the Young STEM Leader program team to make a really cool session that hopefully you will enjoy. Now, this is a little taster of an online module that we've also been making, which will be available on the Young STEM Leader website soon. We don't have an exact date yet, but in December, January, hopefully that sort of time, we'll have a module for you to do on the Young STEM Leader website, which will help you get your Discover badge at level 2, 3, or 4, and whichever level you are working at. So keep an eye out for when that is launched. But for now, we'll get stuck into this session, which is all to do with the ocean, and it'll give you a little idea of what is in store for that module as well. We're going to be looking at what lives in the deep sea, what we've learned about the deep sea, some cool scientists who have been exploring the deep sea, and hopefully inspire a little bit of excitement for the ocean and deep sea exploration. Now, I won't be able to answer your questions during the session, but my email address is up on the screen there. So if you do have any questions that you think of throughout the session and that you want to send through to me, feel free to send me an email and I'll get back to you when I can. So my email address is there just now, chris.george@dynamicearth.co.uk. It'll also be up at the end of the presentation as well. So we'll get started. For this session, you're not going to need an awful lot. You're going to need a pen or a pencil, so something to write with. You're going to need a piece of paper or a little whiteboard if you've got one, just something to write on, and then something to pass around. So we've suggested a ball, but it can be literally anything that you can hold and pass to someone else. This is for an activity later on, and you will be passing something along a line of people in a little group. And we also need you to have someone else to chat to. So we'll be asking you to think about some things, come up with some ideas, and you'll need to chat to some of the people around you to get some ideas from them as well and bounce some things around. Now, I'll give you a couple of minutes in just a moment to get all of these things if you don't have them already. But for now, I just want to start us off with a quick video which will put the ocean in context. So it'll make sense why we're talking about it today and give you an idea of how important it is. And then after that, I'm going to ask you a question about it as well. So we've got our video here.
Our blue planet. Over 70% of the Earth's surface is covered by a vast ocean. Many ocean basins form one connected global ocean. It's the largest living space on Earth. It's where life is first thought to have evolved. The ocean is also our life support system. Always moving, the ocean distributes heat and nutrients on a global conveyor belt of currents. It determines our weather, controls our climate, and makes our planet habitable. The ocean supports a huge diversity of life. At the surface, billions of microscopic plants capture the sun's energy and form the basis of complex food webs. Most of the ocean is deep and dark. But it's far from empty. The deep sea teems and glitters with life, all the way to the very bottom. Yet only a tiny proportion of the deep has been explored. As science and technology advances, we're beginning to understand just how important the ocean is to our future. We are connected to the ocean in many ways, and what we do affects its ability to sustain all life on Earth. Our carbon emissions are making the ocean more acidic. The seas are warming. And the ocean is now changing at a rate that has never been seen before in Earth's history. Exploring the ocean helps us to understand what these changes mean and what we must do to protect our life support system. The future health of our ocean is in our hands.
Okay, so lots to think about in that video. So lots of information about why the ocean is important, what we get from the ocean, what we use the ocean for, how it's changing. So hopefully that's given you an idea of why it's an important topic for us to be talking about. And that brings me to my first question, which is, why is the ocean important? So think about what we use it for, what we get from it, all those things. Why is the ocean important to people, to animals, to plant life, to everything? I'll give you a couple of minutes to think about this, and you can write down answers if you like, or you can just discuss it with the people next to you. Now, I'll turn my camera and mic off so I'm not buzzing about distracting you, and I'll be back in a couple of minutes when the timer is up. That is your time up, everybody. I'm sure you came up with loads of really good reasons why the ocean is such an important place for people and for loads of other stuff in the world. So we're going to give you some examples of some of the things that we came up with, and you can see how many of them you got as well. So we've come up with 10 different examples of why we think the ocean is important. So here are our 10. And I'll go through them all really quickly, and you can see if you came up with the same things and the same reasons. So first of all, habitats. It's the largest living space on Earth. The ocean takes up most of our planet, and it's the largest area that creatures can live in. There's also CO2 and climate. So if you've ever heard of carbon dioxide, a greenhouse gas, then that goes into our atmosphere, that contributes to climate change and global warming. Now, the ocean actually absorbs loads of carbon dioxide. That was mentioned in the video just before as well. So that actually helps slow the effects of climate change too. So it affects our climate. Sport and exercise. So I've never been jet skiing or on a speedboat or anything, but if you go swimming or snorkeling or scuba diving, that's something that millions of people around the world use the ocean for. There's tourism as well. So if you go to the seaside in Scotland or across the UK or abroad, you might go and swim in the sea and enjoy yourself if you're a tourist. We've got the weather. So similar to the climate, it can affect the weather we get every day. So it can affect whether we get windy weather or sunny or rainy weather, because the ocean can change a lot of things about the environment above it. So the air will be affected by the ocean too. And you get different weather on the coast or far inland in a country as well because of the sea. Nutrients, again mentioned in the video, lots of nutrients are moved around the ocean, around the world, that different creatures will eat. So some nutrients will be moved from, for example, one side of the Atlantic Ocean all the way to the other. And that gives lots of plants and animals the nutrients they need to survive. We've got temperature, similar to weather and to climate. It affects the temperature that different places experience around the world. So, for example, the ocean absorbs a lot of heat. So if we didn't have the ocean, the planet would be a lot hotter. So it changes temperatures. We've got food. So we've got people go fishing and we eat a lot of fish, sea creatures, and lots of different seafood. from the ocean. And so it supplies a lot of food to a lot of people around the world. And health and well-being. We often feel better if we go to the beach. So we go there not only for exercise and for tourism, but just to make ourselves feel a little bit better too. And for energy. So if you've heard of wave power, tidal power, anything like this is all because of the ocean. So it provides lots of different kinds of renewable energy. So there are lots of different reasons why the ocean is important. And you might remember from the video before that the ocean is huge. It's changing all the time. And the only way we can understand these changes and understand how all of these things might be affected is to explore the ocean. So how do we even explore the ocean when it is so vast? Well, to understand that, we're going to go back 150 years to the HMS Challenger. Now, this was a ship, here we go, 150 years ago that went around the world. So this was in 1872, and it was traveling the world to investigate what lived in the ocean, and particularly what lived very deep in the ocean. Because at the time, in the Victorian era, a lot of people thought that nothing lived in the deep sea at all, because it was too deep, too dark, too cold, too terrifying for anything to live down there. So the crew went on this trip around the world for about 4.5 years to prove them wrong, prove the people of the time wrong, and tell them that there were things that could live in the deep, dark sea. And the reason why we find it an interesting voyage in particular here at Dynamic Earth is because the chief scientific officer, this fella here, Charles Wyville Thomson, he was a Scot. He was born in Linlithgow and he went to school and university in Edinburgh. And so he was the chief scientific officer on this boat that went around the world to discover what lived in the ocean and how deep the ocean was. So this was 150 years ago that they started to explore what lived in the deep sea. And what did they find? Well, we've got a few pictures here of some drawings that they made of creatures that they fished up from the deep sea and some of the shallower waters as well. So we've got a lot of weird and wonderful fish. You might recognize in the middle at the top, that's an anglerfish, the one with a little lure on the top that glows, that tempts some prey in, and the anglerfish will eat it up. We've got some anemones as well, and we've got squid and octopus, creatures like these, which are very squishy and have lots and lots of tentacles for catching prey. So lots of creatures that we didn't know existed, and some creatures we knew existed, but we had no idea they could survive so deep down. So they were discovering thousands of new creatures, and creatures that we didn't know in Western science existed at all. But they were having a bit of a problem when they were bringing a lot of these creatures up from the very depths of the ocean. Now, a lot of these creatures, they are adapted to live very, very deep in the ocean, where it is very cold, very dark, and they are under a lot of pressure as well. When you bring these creatures up to the surface, up to dry land, or even just up to shallow water, they're not adapted to this environment. So something was happening to these creatures. I want you to have a think about what could be happening to these creatures when they brought them up to the surface and their environment was different. I'll give you 1 minute to chat to people next to you and come up with some ideas, okay? I know that 1 minute isn't an awful lot of time to discuss this, but I'm sure you've come up with some great ideas. And it is a little bit of a tricky question, but The answer is, when they were bringing these deep sea creatures up to the surface, a lot of them were expanding. They were swelling up. Now, if you came to our Young STEM Leader Week event last year, then you might have an idea of why and an example of a creature that this happens to. But I'm going to go through it again this year in a slightly different ways to remind you if you didn't see it last year or if you can't remember. Now, to do this, I am going to use this syringe that I have been fidgeting with. So what I need to do is pop open the syringe and I'm going to add some of these. Now my camera isn't working very well, so I can't see if this has gone into focus, but you should be able to tell that we've got lots of marshmallows in this beaker. So I'm going to pour some marshmallows into the syringe. I'm not going to eat any of them because they are quite gross. They have been used for lots of scientific experiments over the years. Now, what I'm going to do is I'm going to pop the plunger back in, but I'm not going to squash the marshmallows. No, I'm going to leave it just above them and push it no further. Now, what I want you to imagine is that in this syringe, all of these marshmallows, they are all deep sea fish swimming around in the deep sea in their natural environment, okay? What I'm going to do is I'm going to cover up the end and then hold on to the syringe. And then when I pull on this plunger, we're going to see what happens. And you should be able to see that when I pull the plunger up, then our deep sea fish will expand. So I pull it up, and it's quite difficult to do to change the pressure, but they swell up, and then when I let go, they shrink. Now I can also show you that if I have the plunger up at the top, and then I push down, then our marshmallows will also shrink as well. So this shows us what happens when we change the pressure in the animal's environment. So all of our marshmallow deep sea fish, if we decrease the pressure by pulling it up, then they all swell up. That's what was happening to the deep sea fish that the HMS Challenger crew were bringing to the surface. And if the HMS Challenger crew were going to try and dive down to the deep sea themselves, and they weren't adapted because they are humans who are not adapted to live in the deep sea, they would be crushed. They'd be crushed by the huge amounts of pressure. So this is what was happening to our deep sea creatures. They were all swelling up and expanding when they were brought up to the surface. Now, there's an example that I used of a deep sea creature that this has happened to at the event last year, and you might have seen it before, either at that event or on the internet, because one example of a deep sea creature is the blobfish. Now, you might have seen the picture on the right before. The blobfish has been called the ugliest creature in the world, which I think is a little bit unfair because it doesn't normally look like that. A blobfish in its natural environment looks like the picture on the left. And that's a fish that has been squashed by all that water, a few miles of water pressing down on it and squeezing it into shape. So it's adapted to live in that high pressure environment. When you bring a blobfish up to the surface, it expands, it swells up. So it made it really difficult to study what lived down in the deep sea. So that was an issue that the HMS Challenger crew hadn't quite worked out how to solve. They weren't adapted to go down into the deep sea and study all these deep sea creatures in their natural habitat. So it wasn't until we could dive down in different contraptions that we could investigate the deep sea creatures a little bit more. In the 1930s, we had two scientists, William Beebe and Otis Barton, dive down in this contraption called a bathysphere. You can see it's quite small, especially compared to them, so they really had to squeeze in quite tightly together. And they went down into the sea, they started diving down, and they got to about 200 meters before it started to leak. They thought, probably not safe to dive any deeper, we'll come back up to the surface. It wasn't until the 1960s, which was about 30 years later, that these two, Jacques Piccard and Don Walsh, went all the way down to the bottom of the ocean. And not only that, they went to the deepest part of the ocean in the world. Now, some of you might know the name of this part of the world. It is called the Marianas Trench. So well done if you knew that already. This is 11,000 kilometers deep. So that's about 7 miles just straight down into the deep sea, all the way down to the sea floor. So they managed to get all the way down to the bottom. And at the depths of the ocean where there's no sunlight, there was lots of different creatures that lived down there, like our blobfish, but also lots of other species too. And they realized that life was a lot more complex than they necessarily had thought before. And we are going to investigate just how complicated it is with another activity. Now, we're going to be looking at a food web. If you haven't heard of a food web before, don't worry, it's not actually that difficult to understand. A lot of you will probably have heard of a food chain before, and a food web is just lots of different food chains combined together. So, for example, you could get a food chain where the sun makes some grass grow, and then a rabbit will eat the grass, and then a fox might eat the rabbit. That's an example of a food chain where energy is being transferred from the sun to the grass, and then the grass to the rabbit, and then the rabbit to the fox. But that's not the only thing that can happen when grass grows. You can have lots of different food chains that come up. So for example, the sun makes the grass grow, and a cow might eat it, or a sheep might eat it, or a rabbit might eat it. And then the rabbit's not only going to be eaten by a fox, it could be eaten by a hawk, or maybe a wolf, or maybe a bear. So there are lots of different food chains that could happen. And it's when you put all these food chains together that it creates a food web. Now, we are going to look at an example of a food web that takes place in the deep sea. So what I'm going to do is show you 6 different creatures. We've got them popping up just now. And these are going to be our 6 different examples of members of a food web from the deep sea. So I'll go through them all so you know what they all are. First of all, we've got a squid. So a squid, you're probably a lot of you familiar with already. It is a predator. It eats fish, and it's got long tentacles, and it's also got a sharp beak underneath where its mouth is, and it uses this to eat its prey. We've also got jellyfish. So a jellyfish is another predator. It uses stinging tentacles to catch its prey. You might have seen jellyfish wash up on the beach before. They do wash up on the beach around Scotland quite a lot. We have got fish. Now the fish I've got here looks quite different from the fish in the presentation there. The fish in there is called a halosaur, and you get lots of them in the deep sea. We've also got shrimp. So you might have heard of shrimp before. We can eat shrimp. They're little crustaceans, a bit like crabs and lobsters that you get in the deep sea. You get a lot of them off the west coast in particular, snapping their claws. So when you record any noise from underwater, quite often just get thousands of shrimp snapping their claws at the same time. We've got detritus. So this is our little tub of detritus here, and it's just some dirt and soil and mud and sand. Basically, detritus is just all the stuff that sinks to the bottom of the ocean. So when a fish dies and it sinks to the bottom of the ocean and it rots away, it makes a kind of sludge at the bottom. That makes detritus, which is food for a lot of creatures. And finally, we've got our isopod. So here is our isopod here. You might not have heard of an isopod before, but you've probably seen one before, because if you've ever seen a woodlouse or slater, then that is an example of an isopod. It's just one that lives on land. So you get isopods in the sea as well. They've got shells just like slaters. They're little creatures that scuttle around looking for food on the sea floor. Now, that was a lot of me chatting. I promise you, you are about to do your own activity and get involved in this food web. The way this is going to work is I'm going to give you about 4 minutes, and in that 4 minutes, you're going to choose 6 volunteers, and each of you is going to be one of these different creatures. If you like, you can write down which creature you are on a piece of paper, or you can just try and remember. Then you're going to need that thing that you're going to pass around. So we suggest a ball, but it's whatever you've chosen that you can pass around between all the volunteers. That's going to be your energy in the food chain. So you're going to pass it up the food chain to the predator. So, for example, you give the ball to the detritus. The detritus is going to be at the bottom of the food web. Now, detritus, you need to pass it to any creature you think would eat you. So if you thought a fish would eat detritus, you give the ball to the fish. And then fish, you have to pass the ball to anything that you think would eat you. So if you think a squid would eat the fish, you'd pass it to the squid. And then if you think that's the end of a food chain, start again and try and do a different one. So you'll start with the detritus every time, and detritus, pass it on to whoever you think would eat you, and then keep passing it up the food chain to the top predator. There are lots of different potential food chains. There's not just one answer. So try and do a few in the 4 minutes. And then at the end, I'll go over all the different possibilities and you can see which ones you got right. Okay, so I'll start the timer now and I'll be back in a few minutes' time. Okay, everybody, so your time is up. So volunteers, you can go and grab a seat again if you haven't already, and we will go over the different possibilities for our food web and all the different food chains that you might have made. So we have got all of our different creatures here and our detritus, which isn't really a creature. So 6 different parts of our food web. Now, remember, you always started with detritus. So detritus will be at the bottom of your food web every single time. It'll make the basis of each food chain. So that'll be on the left-hand side, and we'll see how the energy goes up our food chain. So there we go. We've got them all moving around. And here is what it looks like. We have got our detritus being eaten by isopods and shrimp. So isopods, remember, they're like little slaters. They will eat anything that falls to the ground, just like woodlice will too. We've got shrimp eating the detritus too, but the shrimp also eat the isopods. So the shrimp are big enough to eat any smaller creatures, but a lot of things are bigger than the shrimp, and a lot of them eat them too. So people eat shrimp, and so do fish and jellyfish and squid. They will all go for shrimp as tasty sources of protein. And fish will get eaten by bigger predators as well, like jellyfish and squid. But you might have noticed that there isn't really a top predator in this food web. We have got jellyfish and squid as 2 top predators, and they will eat each other. So there isn't really one that comes out on top. So if you said that squid eat jellyfish, you were right. And if you said that jellyfish eat squid, you were right. It'll depend on a few things like the species and the size and how fit they are, if they're unwell, if they are healthy, or if they are small, or if they are young, or if they are old. Lots of different things can affect if a jellyfish eats a squid or a squid eats a jellyfish. So we can see that there are quite a lot of different possibilities in our food web using these 6 different parts of it. And we know that thousands of things live in the deep sea, so there are going to be way more possibilities than we could show you here. So lots and lots of complicated relationships between creatures in the deep sea. And all of these creatures are very, very different. So they can all survive in the deep sea because they've got different adaptations. And that's what we're going to look at next. So we're going to investigate some more adaptations that other creatures have. So I'm going to introduce a few more animals to you, and I'm going to go through what they all are, and we're going to try and identify what adaptations they have that help them live down in the deep sea. So here are our 6 different creatures. So I'm probably going to butcher the pronunciation of this first one, but Brizingida. It is a starfish, so you can see that in the top corner, the bright orange one. We've got a cutthroat eel. They are actually known to be quite friendly and quite inquisitive, despite the name cutthroat. So whenever you send, for example, a robot down into the deep sea to explore, we call those ROVs, or remotely operated vehicles. They'll just go up and explore the robot and see what's going on. They like to see what's new, and they will just eat whatever they can find. We've got the chimera below it. That is a kind of shark. It's unofficially called the ghost shark as well. You can see it looks a little bit ghostly in that picture. Next to it at the bottom, we've got the false boarfish, a kind of flat but tall fish that lives deep in the sea. We've got an octopus. I'm imagining a lot of you have heard of octopus before. So you get octopus down in the deep sea, and we've got bamboo coral. So you might be surprised to hear that we've got coral reefs off the coast of Scotland. You get coral reefs all over the world, and bamboo coral is one species of coral that lives in coral reefs. Now, these are 6 different things that live down in the deep sea. And we've got 6 different adaptations that these different creatures have. I'm going to give you a couple of minutes to chat to the person next to you and try and decide which creature has which adaptation. One of these will match up with one of those creatures. So you don't need to write it down if you don't want to. You can just chat about it. I'll only give you 2 minutes. Now, if you think you've worked out all of the adaptations and which animal has which adaptation, try and think about why they might have that adaptation. Why is that useful when they live in the deep sea? Okay, so I'll start your timer. Okay, everybody, so your time is up. Now, don't worry if you didn't quite match up all of the 6 adaptations to the 6 different creatures. It was just to get you thinking about the different adaptations they might have and why they might have them as well. So we're going to go over all of the different answers. So I'll click on each one, and then hopefully we will be able to see each adaptation move over to each different creature. So we'll start off with no air in the body, and that goes over to our octopus. So octopuses can live in the very, very deep sea, but they also come up to shallow waters at the very top of the ocean as well. Now, they're very adaptable because they're very, very squishy, and they don't have any air in their bodies, which means that they don't get crushed and injured. We have air inside our bodies, and that's one of the reasons that if we go down to the deep sea, it actually squishes all of the air out. And as you can imagine, if we can't hold any air in our bodies, that's not great for us surviving. So octopus has that very clever adaptation. Now let's go down to glowing. Now, the animal that glows is the bamboo coral. Now, there are a couple different theories about why the coral glows. One of them is that it might scare off predators. And there's another theory that is if it's disturbed by a predator and it starts to glow, then that will attract the attention of a bigger predator that will eat that predator as well. So there are a couple of different ideas as to why things in the deep sea might glow, but one of the main ones is to scare predators away or to attract attention as well. Now we've got eats detritus. I didn't say what detritus meant because I hoped that you might remember what it meant from the food web we just did before. And that one is our cutthroat eel. So remember I said it likes to appear and it will eat anything that's down on the ground. It eats lots of detritus that has fallen from higher up in the ocean, rotted away and down on the ground. Plenty of food for a cutthroat eel. Now, a cutthroat eel is not called a cutthroat eel because it is aggressive and it's got a cutthroat nature. It literally looks like its throat's being cut. It's got these little V-shaped gills at the side, which look a little bit like a little cut in its skin, but it's actually quite friendly and not dangerous. Now, let's move up to 20 arms. Now, looking at what's left, you probably can work out that that belongs to our starfish. So you might not have counted every individual arm on the picture, but they have lots and lots of arms, and they use these to catch any little bits of food that drift past them in the deep sea. And that leaves us with our chimera and our false boarfish. And one of them, the adaptation, is particularly big eyes, which is tricky because they both have quite big eyes. But this is a main adaptation of the false boarfish. Now, it's got big eyes because it's so dark down there that it can't really see a whole lot. So if you've got bigger eyes, then you can take in what little light there is, so you can see a little bit more. And that means that our chimera can detect electrical fields. Now, chimera, also called a ghost shark, like other sharks, can detect electrical fields. So bigger sharks and sharks you might have heard of before can detect electrical fields and impulses from other animals because we all have electricity in our bodies, and sharks can detect this electricity. So scientists reckon that chimeras can detect electrical fields because it means they can tell if there's any food around or potentially warn them of if there are any predators nearby as well, even if they can't see them in the dark ocean. So those are lots of different adaptations that we see in the deep ocean. And the only reason we know about these is because of deep sea scientists. So they make all this research possible. And we've got some deep sea scientists here. So you can see them in lots of different situations doing lots of different kinds of research. So we've got deep sea scientists who go out on boats and study the ocean when they're right out in it. We've got deep sea scientists who will study the industry related to the ocean. So you can see one of them in lots of protective gear at the bottom there. We've got scientists who will work in a lab as well, or out in the field, out by the coast on the shore. There's lots of different things to study, and there's lots of ocean yet to be explored. And we only know as much as we do because of their work. Now, we're going to finish up soon, but we've got a few videos that we want to show you of some scientists talking about the work that they do and telling us why it is important.
Worldwide, fishing communities are concerned that fish stocks are overexploited. And here in the Berkshire Marine Reserve, I work with local fishermen and women to better understand the local crab and lobster populations for the future management of these stocks. I work on the fishing vessels and I record the number of these animals, the length of these animals and the weight of these animals, and we add this to future data and information to see if we can help better the management of the stocks. Whilst I'm out on the fishing vessels, I also record video footage of these animals to see whether or not the social interactions can influence the number of animals caught at the end of each fishing trip. By working in sustainable fishing research, I hope to have a positive impact for the local community and also for the future generations to come.
Okay, so Blair studies populations of crabs and lobsters, so creatures that we eat and that fishermen and women will fish for and use as food supplies and make money from. And we want to make sure that we're not eating or catching too many of them. So scientists like Blair will help make sure that we're being sustainable and that people can still make money from their jobs and that we've still got enough food to eat. Because we don't want the populations of these animals to go down and we don't want our food supplies to go down. Now, our second scientist is named Bhavani. So this is Bhavani, and she'll tell you about her research as well.
I'm looking at animals that live on and in the sediment at about 2,000 metres water depth and just a day's steam off the west coast of Scotland. I use something called an epibenthic sled to collect these animals, and my team and I then bring them back to the lab where we sort and identify them. I'm using both historical and more recently collected samples to look at changes in species type over time and relate this to variations in water temperature and food input and the potential changes in climate. The deep sea is really important for a number of reasons, ranging from the high diversity that we see in some locations through to its ability to capture and store large quantities of carbon, as well as the potential for discovery of new medicines beneficial to human health. I find it fascinating exploring and studying the deep sea. There is still so much yet to be discovered, and as a result, the world's focus is slowly turning to the deep sea, and it also allows for greater global collaboration.
So Bhavani's research looks at the sediment down in the deep sea and how that has changed over the years. Because like that video mentioned at the start, the oceans are changing. And that sediment, that detritus, all the stuff down at the bottom of the ocean, if we study that, we can see how things have changed over the years. So for example, if the ocean's gotten warmer because the planet's gotten warmer, then we'll see some changes down there in the sediment and in things that live down there too. And there's some really amazing stuff that we can learn more about, like potential medicines from things we can find down in the deep sea too. So that's what Bhavani's doing. And lastly, we have got Nadia.
Coral reefs are teeming with life, but unfortunately they're under threat due to human-made influences such as climate change. But some corals are more resilient to these changes than others. I use CT scanning technology to look at the skeletons of corals to understand why some are more durable. And with this information, I can then start to build a picture of what future reefs might look like in a changing ocean. This is really important because 500 million people worldwide rely on coral reefs through industries such as tourism and fishing. Now's a really exciting time to be a marine biologist because governments and the public worldwide are realising just how important a healthy ocean is to solving some of the world's biggest problems that humans face today.
So Nadia is studying coral reefs. So you'll probably be aware, you might be aware, that there are coral reefs in tropical places. So the Great Barrier Reef off Australia's coast is probably the most famous coral reef, but we've got coral reefs off the coast of Scotland too. And lots of creatures live there, and Nadia and scientists like Nadia are studying coral environments, and that gives us an understanding of what lives there and how that's changing over the years as well, and how it might change in the future. And it also helps give information to people who work in environments that rely on coral, such as tourism and fishing as well, to make sure that they can do their jobs and that their jobs won't be in trouble in the future as well, and that we can protect the coral that they rely on. Now, that was our last scientist that we were going to look at, and it brings us to the end of the session. But I just wanted to remind you that we will be releasing an online module soon. It'll be up on the Young STEM Leader website. So wherever you upload your logbook information, it'll be on that platform too. So got a little sneak preview about what it might look like. So there'll be videos, there'll be activities, there'll be discussions you can have, there'll be things that you can make, all to do with the ocean. So it'll be ocean themed, a little bit like the session today, and it'll be a way for you to gain your Discover badge at level 2, 3, or 4, depending on what level you are working at. Now, this is brand new for us, so we're really excited that we've been able to work with the Young STEM Leader team to make this happen. So we hope you enjoy it. As I say, we don't have an exact date for it launching, but it will be soon. So keep an eye out, keep your ears perked up for any news of that module. And you'll learn about the ocean, even more reasons why it's important, even more things that scientists are doing to explore it and explore what those changes might look like. And that brings us to the end of our session today. Now, I hope you have enjoyed doing the activities and learning about what deep sea scientists have been researching over the past 150 years. If you do have any questions about anything that we've been doing today, feel free to send me an email. I will try and reply to you as soon as I can. But otherwise, I hope you've been enjoying Young STEM Leader Week so far, and I hope that you enjoy everything else that you do as part of it too. And maybe we'll see you at Dynamic Earth in the future one day as well. You can see our brand new ocean gallery and do lots of other activities all to do with the ocean, but stuff to do with volcanoes and outer space and rainforests, lots of different things all about planet Earth. So thank you very much. I've been Chris. It's been lovely delivering this session for you, and I hope you enjoy the rest of your day. Bye-bye.